Good day, everyone. Welcome to the webinar. On behalf of VSC Spectrum and Trinity Consultants, we'd like to thank all of you for taking the time to attend part one of our two-part presentation on the role of the DAS and some best practices. The second half of this presentation will be made available by webinar shortly. Currently is scheduled for May 14th, same bat time, same bat channel. My name is Steve Argabright, and I'm a CEMS Specialist and Senior Consultant for Trinity here in the DFW area. Joining me today for this presentation is Mr. Adam Jackson. Adam is with ESC Spectrum, a Business Development Coordinator. Say hello, Adam.
Hello, my name is Adam Jackson. I'm a Business Development Manager with ESC Spectrum. I'm based in the Houston area. ESC is one of the largest DOS fighters in the United States, and we specialize in CEMS integration and OEM analyzer support. Steve?
Both Adam and I, just a little background about ourselves, we both have considerable experience with data acquisition from the regulatory, the software, the hardware side. We've both done plenty of field work with these systems for many, many years and currently plan to do it for many more. We will be asking our participants, everybody who's listening in right now, to post questions during the webinar, and we will try to answer as many of them as we can. Based on the number of attendees that we have today, obviously we probably won't be able to get to all of them, but we will try and answer as many as we can. Adam, can you identify to the attendees where they can post their questions?
Sure, Steve. So if you look in the GoToWebinar control panel, you'll see a questions pane. If you ask your question, just type it in. You can send privately or send to all. I will be in the background compiling the questions and answering as we go along. When we get to the end of the presentation, we're going to have a short Q&A session. Just like Steve said, we may or may not get to all the questions, and so I'll be working feverishly to prioritize, and whatever we don't get to, we will make sure to email you a response.
And Adam, do you have anything else to add before we begin?
Nope, Steve, take it away.
All right, fantastic. Okay, today's presentation, part one of this presentation, is the role of the DAS, the Data Acquisition Handling System, and some best practices. This is a joint webinar between ESC Spectrum and Trinity Consultants. Once again, I am Steve Argabright, CEMS Specialist and Senior Consultant with Trinity here in the DFW area. Adam Jackson, our Business Development Manager, is with ESC Spectrum as our co-presenter today. Quick overview of ESC Spectrum. Based in Austin, ESC Spectrum provides the most widely used CEMS data acquisition system, DAS software, known as Stackvision, in the United States. DAS is the market leader in helping the industrial and utility plants comply with federal, state, and local air quality regs requiring continuous monitoring. Their professional CEMS services staff provides expert integration, maintenance, repairs, training, stack testing, and more. Trinity, since our founding in '74, have expanded our geographic footprint and breadth of services. We attribute our continued growth to a focus on cornerstone values of top-notch technical performance and excellent client service. We deliver solutions uncommonly well. We have offices in just about every state out there. We're passionate with our customer service. We try and answer everybody's questions as quickly as we can. Let's begin. The DAS, the Data Acquisition and Handling System. What does the DAS do? Your DAS is the brains of your CEMS. It collects and manages data from many continuous monitoring systems, whether that is an emissions monitoring system, a parametric monitoring system, opacity monitoring system, particulate matter, what have you. It's not just a passive data logger. This is where your data is validated. This is where your calculations occur. This is where your averaging happens in the DAS as it is collected in real time and not just later in the spreadsheets. A true DAS, you have alarm signals and data available in real time as it occurs. Now your IO is collected by the data controller or programmable logic controller, the PLC, and your regulatory requirements for data collection, whether that is 40 CFR Part 60, Part 75, Part 63, etc. It's all programmed usually within your DAS server software and your controller hardware. When it comes to the subject of general obligations, most people fall under somewhere between Part 60 or Part 75, sometimes both. Under Part 60, your performance specifications occur in Appendix B, those specifications that you have to perform to. Appendix F under Part 60 gives you the quality assurance procedures, and Appendix F to Part 60, Procedure 1, Section 5.1, also known as your data accuracy assessment and auditing requirements. Under Part 75, where everything is co-related, you have Appendix A that points out your specifications and test procedures, your QA procedures under Appendix B, and the conversion or calculations that occur under Appendix F. You have an obligation under Part 63, specifically the data collected during breakdowns, out of control periods, repairs, maintenance periods, any instrument adjustments or checks to maintain precision and accuracy, cal checks, low level, mid level, high level, where applicable, any adjustments, you have to collect that data. Now, regardless of the Part 60 and Part 75 rules, there is the operating permit. And whatever Part 60 and Part 65 says, when these rules are referenced in your operating permit, interpretations of those rules tend to become fixed, sometimes so fixed that they become specific to your facility. They can reconcile rules that clash, they can reconcile consent decrees that you're under, or they can become much more strict. When it comes to the regs, good communication is key, because under Part 60, those regulations can be very silent and often vague on many of the quality assurance and data validation issues that you encounter. Because it's interpreted on a state-by-state basis, it can lead to inconsistency amongst the agencies. Each state administers these Part 60 regs in their state, and it can be a nebulous process. It's important that you should review and understand the expectations of your state and your local air control agencies. Part 75, on the other hand, the regulations are more explicit and, quite frankly, I think better explained on quality assurance and data validation issues. There is greater consistency of the regs. Part 75 is administered at a federal level, and while it can be more stringent in a regulatory fashion, it can be a lot easier to follow with clearer expectations. I would reference the plain English guide to the Part 75 rule and the emissions policy, the updated emissions monitoring policy manual as reference guides for understanding all things Part 75 related going forward.
And Steve, I would like to add, this is Adam Jackson with ESC Spectrum, on the Part 75, that for our folks and clients that are on the phone right now with us today that aren't in the power industry, they may not be aware that Part 75 is typically specific for power generation. When looking at these two and trying to do comparisons between Part 60 and Part 75, it's always good to start with Part 60, Performance Specification 2. And if you read Performance Specification 2, a vast majority of all the other requirements from both Part 60 and Part 75 were built upon that foundation. All right, go ahead, Steve.
That's very true. That is very true. Your monitoring plans. This can be the heart of your data acquisition and handling system. And first and foremost, you should know them. And by that, I mean your current monitoring methodology, what kind of equipment you're using as a result of your monitoring plan, and any formula that is inherent to that plan for doing your emissions calculations. You should reconcile and update them periodically. And when I'm talking about modifications, I'm talking about resubmitting them ultimately. Checking, doing span evaluations periodically if you're required to do so, and possibly having to update maximum potential concentrations, maximum expected concentrations, those things that historically you have output from your system, updating any date and hour entries, etc. You should always have access to them because you never know when somebody's going to show up from the agency and ask for them. That would be for both electronic and hard copy updates. Your monitoring plan is so critical that you should actually make QA checklists from them. And by that, we're referring to the daily, weekly, monthly, quarterly, semi-annual, or annual walkdowns that are requirements for just about any system out there. Your monitoring plans guide the configuration of your data acquisition system and the QA/QC that ultimately becomes embedded in it, and that is what tags you're monitoring, how it's configured, how it's scaled, what precision do you have to report these parameters at, how often the data is collected, how often you calibrate the system, any other recertification testing. All of this is guided by your monitoring plan. Adam, can we
Steve, I
talk
would like
about
to.
monitoring plans a little bit?
Yeah, I was about to jump in to discuss the monitoring plan itself. Used to have to be submitted every time you submit an EDR with ECMPS. Now the scenario is once you submit a good monitoring plan, you're good to go. The monitoring plan can be updated at any time, and this is a key distinction between it and actually submitting EDR data. So QA results and monitoring plans can be submitted and updated anytime through ECMPS. And so when we do a DOS audit, when Trinity comes to your site, performs DOS audit on your system, this is one of the first documents that they're going to ask for, and they're going to look for, and they're going to go through and look at your plant configuration. They're going to be looking for stack configuration, serial numbers, monitored parameters, and any of those things that are incorrect could be construed as a violation. So updating the monitoring plan should be done at least on a quarterly basis. It's not information that changes often, but when it does, it's very apparent. Also, you should note that monitoring plans are public information, can be searched by the public, and can be found online. Thanks, Steve.
One other thing, Adam, as far as we're talking about the distinction between electronic and hard copy monitoring plans, if I was going to, update my hard copy monitoring plan, what would be my impetus to do so?
Yeah, the main drivers for keeping the hard copy on site are plant changes, configuration changes. You've changed an analyzer, maybe fuel has changed at your site, fuel flow numbers have changed. There's a very long list of items that go into this monitoring plan that do, in fact, build out your DOS. And so as you're going through doing your EDR, you want to make sure that you're going through that checklist to make sure the DOS accurately represents what is at the site. And that's the intent of this monitoring plan document. Now, I've asked questions over the years as do we need to have the hard copy monitoring plan? Response from Region 6 at one point in time was no. As long as you've submitted it through ECMPS, you're good to go. My best practice is I've always got a hard copy of it because you never know when you can't get access to your system. So make sure that you do have a hard copy. It's sitting in your CEMS QA/QC manual ready to go for anybody to review, and that the drivers are put together into a checklist for you. And then that checklist could be built directly off of this monitoring plan. And you can drive that through your CEMS QA/QC program.
Okay. So let's move on to the data flow. And here's pretty much how the information passes from your CEMS into your DAS. Starting at the analyzer portion of your CEMS, that which would be overseen by your equipment, your electrical instrumentation techs, your instrumentation and control technicians, plant techs, whoever you have on site monitoring this equipment. From there, it would pass on potentially to your DCS and the controls group for your operators. From there, it can go on to perhaps an annunciator system or a PI system, plant information system via a data historian, your IT folks. From there, it can wind up ultimately exported into spreadsheets for your plant environmental coordinators, your air quality group. Remember, is looking at the data for analysis for reporting at a state or federal level.
I would like to note here that if you find yourself doing emissions calculations in spreadsheets and you have a DOS, the DOS might not be doing its job. It might not be programmed appropriately, or it might not be set up with a module that you need. The purpose of the DOS is to take this flow of data, to do the calculations, and to present a report in a format that can be used on the external to the DOS. So if you find yourself manually having to pull in minute-by-minute data, compiling it into a spreadsheet, doing missions calculations in a spreadsheet, you might want to go back to your DOS vendor to review that particular missions monitoring requirement to see if there's something that can be set up in the DOS to automate it.
That's an excellent point. Also, remember that the primary function of your DAS is to report information for an agency, meaning that sometimes those tags, those parameters are programmed to a specific precision. And if you begin playing with your data in a spreadsheet, if you're not getting the same results as your DAS, it's possible that you're actually doing it at a higher or lower precision than what the DAS is routinely outputting. Just something to keep in mind as part of the best practices. Know what to look for. So where does data validation occur? When we're talking about data validation, we're generally talking about the status flags that are associated with good versus bad data, valid data versus invalid data. If you're receiving data from an analyzer or a monitor, it can have faults associated with it. Those faults can actually invoke a invalid status flag with it when those faults occur. Those flags would be picked up by your data controller, your PLC. The entire data stream, the value of the tag and the status flag associated with it can be transmitted to a DCS from PyHistorian and ultimately be picked up in your spreadsheets. So the question remains, how and when do you exclude invalid data? Are you excluding it for averaging purposes? Are you allowed to exclude startup and shutdown? Are you allowed to exclude maintenance periods? When do you actually exclude invalid data? It's important to actually know this for averaging and totalization purposes, because sometimes the exclusion of invalid data is what keeps us from busting our caps with those that are identified within our permits. Adam, do you have any examples you want to include for this question?
Sure. And so with data validation, just to be clear, what constitutes a valid hour of data is one monitored point within a 15-minute quadrant across the 4 quadrants. That would be a valid data point. So what Steve is bringing up is, let's say you go through a maintenance event. What you want to do is minimize your analyzer downtime. Analyzer downtime drives things such as how you can do data substitution in Part 75, and it can create a nasty situation where you could have an exceedance if your monitoring downtime is below 90%. So as you go into maintenance, you can optimize, and this is a helpful tip. If your site is currently not doing this, when you go into maintenance, maintenance mode only requires 2 quadrants in an hour. So you can optimize 2 hours, 2 successive hours. You can throw your CEMS into maintenance mode on the 16th minute of that first hour, and then move all the way to the 44th minute of the second hour, and give yourself almost an hour and a half worth of maintenance with 2 valid hours. And so with the validated points, because you had the first quadrant, which is the 15 minutes, and then you operated that 1 point, that first minute of the 16th minute in the second quadrant, that gives you a valid hour. And if anybody has any questions on how to do that, or if you don't think you're doing that, or if you have a question about it, send us a question in the question pane, or you can email us and we can help you with this.
And just to be clear, when it comes to the subject of exceedances or downtime, you can be in exceedance or you can be down, but you can't be both. Exceedances generally by definition occur during normal operation when there are no outward indications of monitoring problems, monitoring issues. Downtime, conversely, is usually associated with faults within the system. You'll usually get a bad status flag associated with it. That is an indicator of downtime. Exceedances normally have no faults associated with them. They just happen to occur normally. And then you have to go back through the process of rationalizing why they occurred.
Yeah, that's correct, Steve. And in terms of exceedances, the exceedance really is the air permit tonnage limit for the end of the year that you're concerned with if you're continually flagging your analyzer is down. So if your downtime number is driving below the 95% mark, below the 90 mark, bad things can happen when you go to calculate your annual tonnage if you have to do data substitution. So it's always in your best interest that if you do go into something like maintenance mode, that you optimize it to reduce the number of hours that are invalid.
Another expectation of your data acquisition handling system, the question that are your tag values, are your parameter values being flagged and or alarmed? This is important in a DAS. You want data status flags from your instruments, good or bad, you want all of them collected. This is a continuous monitoring system. You should be collecting data status flags continuously, whether the data is valid or invalid. Because you're collecting those status flags, that downtime should be demonstrated in any spreadsheet exports that you do, if you have the capability with your DAS. And because those values are being flagged and or alarmed, can you respond in real time to try and avoid these exceedances that we're talking about? This is very important. You want your control room operators to be able to notify somebody that, hey, I've got an alarm coming in. That alarm is usually generated because of the existence of those status flags. Knowing that information as quickly as it occurs does allow you to respond much more quickly.
And as a helpful tip, and this is a best practice, as a prior plant engineer in a gas turbine facility, this can sneak up on you. So if the values are not being flagged appropriately, don't wait till the very last 2 weeks before submitting an EDR to go catch up for the previous quarter. So this is an exercise that I personally would do every week, and then I would have my team get together every month and compile the documentation to support why the data was flagged a certain way. And so this is where your control room logbooks, your CEMS Shack logbooks, and your data from day to day should all match and support your case for if you have to change a status flag or if you're updating something that you didn't know what happened that day.
And this is information that should be widely disseminated amongst the DAS users. If they are participants in the ECMPS program, they have the capability of using ECMPS offline. They don't have to submit the EDRs for you. They can actually evaluate your emissions EDRs, your QA/QC EDRs, your monitoring plan in the form of an EDR, and do it offline and potentially correct any errors in data calculations that might happen, and they do happen. In my prior experience, we had all of our technicians at over 50 units practicing this stuff on a routine basis, pointing out the errors to us every week, every couple of weeks. And we were called in as the first line of defense to try and help them if they couldn't correct these errors on their own. It sped up the process, made it much more efficient, and it really worked out very well. So moving on, when we talk about flagging and alarming values, where do your calculations occur? I mean, are you spreading them across a multitude of systems? Are you doing them in independent places? Can your environmental personnel see and confirm these values, these exceedances, these periods of downtime? Who has permission to edit data? How are you going to document any changes to that data? Who edited it? What user ID did they have? And can you consistently assure and demonstrate compliance with this data? That is an important question to ask yourself anytime you're doing this. Can you do it consistently?
A helpful tip and a best practice here is when I used to be a DOS auditor, and Steve is also a DOS auditor, it's this calculations piece that might be throwing things off a bit. And if you look at all the different DOSs out there, each one has a different way of being programmed, and your air permit calculations are programmed in to demonstrate compliance with the permit requirements. In our platform, ESC Stackvision, you can push a button and print out an entire report of all of these calculations and see them in one spot. And that was helpful for me when anytime that I audited an ESC Stackvision facility. It was very simple to simply go and print the document out. And here's the tip: if you have more than one stack, you should do a code compare with the equations. And if one of those things does not look like the other, that's something that you should have pause and start asking questions and re-review your permit requirements.
Now, both Adam and I have worked on multiple platforms during the course of our career. Any DAS platform that you work on out there should be able to demonstrate proper calculation capability. You should be able to prove out the math of your calculations at will, not only using any wizards or utilities available within your DAS, but also using ECMPS as a benchmark for making sure that your calculations make sense. Anytime an auditor or anyone from the agency asks you to prove out your math, this is what they're asking you to do. Send us proof of your calculations that everything is doing it correctly on an hourly basis, on a quarterly or semi-annual basis, or what have you. Be able to demonstrate that when it occurs. They ask you just, pick a time, pick a date, pick an hour. Be able to prove that your calculations are working under normal operation, that you're, if you're Part 75 and you have to do data substitution algorithms, that you can prove that those work as well. We're going to step back into Part 60 and talk about hourly averaging, and this is covered under Statute 60.13, where they discuss continuous monitoring averaging. And this is an important question for your permits. Is your limit, wherever it's designated, is that, do you have an hourly average that is based on arithmetic averaging, meaning that it uses all the minutes of the hour to average, or does it do integrated averaging, which refers to valid quadrants? And the distinctions still occur out there on a state-by-state basis. Adam, I can't remember which states do this. I seem to remember there were plenty in the Northeast that utilize integrated averaging, but it's been several years since I looked. Do you know of any places that utilize integrated arithmetic? Do they care anymore?
I haven't run up against it in the last, say, 2 to 3 years where I've seen a distinction between the two. But your vast majority of my DOS audits, obviously in Texas, because that's where I'm from, but also in the Northeast, I didn't see any evidence of a distinction between those two there.
So it can be either. There may be a statement in your permit that allows you to use either arithmetic or integrated averaging to create a valid hour. 60.13, I believe, also refers to the harmonization between Part 60 and Part 75 as to what constitutes a valid hourly average during periods of maintenance events. Moving on to the subject of calculating a multi-hour average. Questions you need to be able to answer there is, how many hours do I need? Is it 3? Is it 8? Is it 24? Am I able to exclude data based on startup or shutdown or malfunctions? Am I creating a multi-hour average, or am I creating a cumulative total? Is it rolling? Is it block? Is it based on operating time versus an operating hour for validity? Do I have to be online to create this multi-hour average or multi-hour total? This is important when it comes to your permit. This is important for creating an EDR, for the simple reason that when you're talking Part 75, it's all about being in operation, as opposed to opacity, for example, which can be, based on fan operation, or it can be a 24/7 monitoring operation.
Yeah, it would be helpful for all sites to make a key distinction, especially Part 75 sites that have to report at the federal level, to understand the difference between their calculations that go to the EPA versus the state reporting. And so you may have something like subpart quad K, which is for gas turbine facilities, may have rolling averages that the state may be interested in, and versus your hourly averages for Part 75 that go into your EDR calculations. And so what I did was created a table for myself and posted it in the control room that had all my permit limits and had the distinction between where do we report these things to, and then what type of calculation are we looking at? Because this piece right here is important for preventing the next exceedance. And so if you know where you're at in the hour, or if you're in a 3-hour rolling average, you can back off the units and give yourself enough time to prevent an exceedance. And if the operators understand that, and the control room operators are trained on the permits, and they have an easy cheat sheet for this calculating your averages, it'll be a lot easier for them to respond in the event of a excursion or an exceedance for the NOx, CO, or any of the things that are monitored.
Right. You don't have to be smarter than the DAS. You just need to have a reasonable idea of what to expect from the DAS. Now, as far as data storage and retrieval, depending on which regs you have to comply with, you generally want to keep at least 2 years of your data active, and probably about 5 years total for auditing and agency purposes. It's kind of important to know that if you have a hiccup in your communications, or somebody, cuts an Ethernet cable between your server and the black box that your data goes in, once you restore communications, how easy can you retrieve that missing data? That data, which hopefully is stored in register areas in your black box out there, how easy can you get that back into your server? Do you know the data path? Physically, do you know the data path? How easy is it to trace? With regards to retrieving the data, are there any limitations as far as exporting that information, getting it into Excel for further manipulation? And how difficult is your data management once you do so? Everything's sorted correctly? Do you have to spend a lot of time monkeying around with your spreadsheets to get everything just so? These are all important questions to ask about what can my DAS actually do for me? And am I taking full advantage of everything that's available to me? Adam, do you have any examples of how data management works on your end?
Sure. So ESC Stackvision utilizes 8864 data controller. Other DOS may utilize a PLC. Our data controller actually does the calculations locally. It's built for CEMS. It's a centric focused permit calculation machine. And there's several best practices here for data storage and retrieval, starting with the 2 to 5 years. The 5-year requirement, I highly recommend. And if you don't know whether it's 2 to 5 years, or you don't know the number, stick with 5 years. Title V auditing period requires 5 years worth of data. So as long as you're maintaining 5 years within your DCS historian or your DOS, an agency can come back and ask you and you're in compliance. Also, there's other regulatory agencies that you can use this data, your DOS data, for. There were several times where I was going through in power industry a NERC or FERC audit, and they asked me certain things, and the only data I had was from the DOS to prove operational compliance. On the actual DCS platform itself, make sure that you understand where your backups are. And so you can have a DOS backup, but are you also backing up Pi? Are you also backing up the actual DCS itself? Another helpful tip is to go to your analyzers themselves. Typically, there's a buffer and there's a setting for a buffer of data. It could be 2 weeks, it could be 30 days, it could be a year. Sometimes I've come into these facilities and recognized that something was reset, or the analyzer was restarted, or they simply just updated some firmware and that setting was not on. So if they had a crash elsewhere, you've lost data. So it's a simple setting. You can turn that on. You can have yourself covered with a buffer. In some cases, there's a buffer in the PLC, there's a buffer in the analyzer itself, and then there's a buffer in the data controller. So go check all your buffers to make sure those are activated.
Right, because your ability to recover from, your server crashes, if you have some problems with data collection at that point, it's important to be able to store that information for ease of historic retrieval later, whether we're talking about a data controller or a PLC. Your ability to recover from, say, losing a hard drive on your server can boil down to how much data was I storing out there to begin with. Not just the data, but any calibration events associated with it and the data status flags that went with that as well. Adam and I have worked on multiple platforms like this, whether we're talking PLC or 8864s or whatever kind of data controller you're using for intermittent storage. Seen plenty of instances where a server goes down and the only thing that keeps you going is your ability to store that information while repairs are occurring. I remember that with the 8864, for example, it is possible to do a configuration dump to a text file where you can actually go through and visually confirm the amount of storage that is available for multiple averaging periods on that system. In some cases, yes, you can store up to a year's worth of data depending on the average that you're referring, and I believe the number of tags that you programmed in. Moving on. Oh, before I forget, Adam, do we have any questions rolling in yet?
None at this point. So if anybody has any questions, remember you can ask in the questions pane and we will respond accordingly, and we're going to have a Q&A session at the end that we can talk as well.
Okay, great. With regards to this slide, the continuous monitoring data flow with the DAS, we had talked about this slide previously. This particular slide is meant to indicate that regardless of the data flow, all this information is readily available to everybody in its path. E&I techs can verify validation, they can verify calculations, they can verify downtime or exceedances or reporting. Your operations, your controls group can look at this same information as well. Responsible individual who receives, who has to sign off on the report can go through and look at all this information ad hoc, at will. It's all available with your DAS if you're using full capabilities of it. So now we come to QA/QC and the data acquisition handling system. The slide on your screen right now indicates the actual data flow through a standard system where however much IO you have out there, whatever communication medium that you're using, whether we're talking CEMS or comms or parametric or what have you, this is a potential path for where all that information passes through, where it can be stored, what it ultimately becomes. Adam, do you have any comments here before we move on?
Yeah, I'd like to note that we do have questions coming in, and it's in my pane that I don't see them, so we're working on that right now. We'll make sure that we have all the questions identified by the time we get to the QA/QC or the question and answer session at the end. And as far as QA/QC plan, every time I go to a facility to do a DOS audit, the first document I ask for is CEMS QA/QC plan. And if there's a question about CEMS, if there's a question about DOS, if there's a regulatory question, it should be answered in the CEMS QA/QC plan. And Steve and I have given, I don't know how many CEMS training sessions, Part 60, 75 training sessions, And the joke of the session is that every answer, every question of each of these training classes can be answered by CEMS QA/QC plan. And so the CEMS QA/QC plan should identify the entire workflow you see here in this image, where it starts at the DOS client all the way up through to the stack, each thing identified. And there's several documents out there that help define and identify how to build a proper CEMS QA/QC plan. A document I've used for years is the ESC DOS audit platform. And so ESC has developed their own Part 75 DOS audit procedure, and it's fantastic because it goes through each one of these things that you would have to build out a QA/QC plan, and you can just simply take that document and rework it for yourself. There's also EPA guidance and the Part 75 emissions manual, all this plain English guide to Part 75, all of those documents have QA/QC plan either templates or they spell out the requirements that they're looking for. On a routine basis, the QA/QC plan should spell out the maintenance. And so if you're doing daily, weekly, monthly, quarterly, semi-annually, annually, you should quickly be able to go to a CEMS QA/QC plan, match that up to your maintenance management system. So if you're using SAP, Maximo, MP2, everything that's in your maintenance management system should have a direct logical tie back to the CEMS QA/QC plan. And that becomes your regulatory basis. And so here's something to note as well. On DOS audits, we often find people took some creative liberties in their CEMS QA/QC plan and wrote a whole bunch of requirements for themselves that might not necessarily be applicable to the facility or something that you could read directly out of a permit, Part 60, Part 75. So you should note that you should thoroughly review your CEMS QA/QC plan to ensure that you're doing everything it says. Because once you've put it in writing, regardless of whether there's a regulatory basis or not, the CEMS QA/QC plan then becomes your regulatory basis. So you're essentially setting your own guideline.
It's all very, very true, because we talked earlier about the critical nature of your monitoring plan. Your monitoring plan becomes your QA/QC plan. Everything that, as far as your devices, your analyzers, your operational systems for CEMS and COMS and parametrics and whatever else kind of monitoring system you have out there, all of that information is identified with your monitoring plan. Your QA/QC will be developed as a result of that. With regard to your data controller capabilities, it should be able to validate data as it occurs once we acquire it. The status flag coding should more than likely occur to identify startup and shutdown periods, and if not in the data controller, definitely in the DAS itself. Are you online? Are you offline? It should be able to code based on the QA activities for calibration or maintenance, certain other special situations. It should automate certain periodic activities, and this brings us to the subject of calibrations. You should always be able to identify, hopefully via status flag, when your dailies occur, when you're doing quarterly testing, quarterly calibrations, putting a system into maintenance for quality assurance activities. Even during a blowback, you should be able to identify that particular period, if that is applicable to your system, via status flag code. All of these periodic activities constitute an invalid status, a downtime event in your system. You should be able to readily identify it as such as part of your QA/QC. Whether we're talking a proprietary data controller or PLC, you should have the capability of instantaneous alarming or time delayed alarming. It should be able to readily communicate with other devices in your system, like the DCS, like a PI, or other devices. And its data storage capability should protect you from communication gaps. And it should allow you to achieve the real-time data collection requirements for your unique needs, your site-specific needs. and everybody's is different. Your DAS should automate data processing. It should validate your data or invalidate, as the case may be. It should, at a minimum, be performing those compliance calculations that you rely upon. It should provide graphical displays, dashboards even, for the data flow path, charts, editing tools, an electronic log if you choose to use it, perform calibration checks, provide a relatively easy to use reporting engine, and alarm when necessary. Adam, do you have anything to add before we move on to the last slides? It's possible we may have lost Adam there.
The DOS should be the one-stop shop, and in some cases that might not be possible because of SCADA, gas chromatograph. Maybe there's a limitation for how you can get your communications from point A to point B at the plant. But even then, there should be an import function, and you should be able to utilize your DOS if there's something that's remote that you can't get to. Most of these dashboards for DOS can be built out to put together an entire alarm screen. So best practice is if your DOS offers a dashboard, use it and build it and create the screen and put it in the control room. Oftentimes I go to the facilities and I ask, okay, where's your DOS? Oh, it's out in the SIM shack. Okay, where's the screen? Well, we have to go out to the SIM shack to look at it. Well, where are you getting the alarms? Well, the alarms are being enunciated back to the main DCS. And the problem with that typically is that the main DCS could look like a Christmas tree with a lot of unacknowledged or yellow blinking alarms that have operational alarms that might not mean too much to you at the time. And your CEMS alarm is buried in those alarms. So it's always helpful to have these dashboards and have all your permit requirements built out that it's blinking real bright and red at you saying, hey, look, if you don't pay attention to me, we're going to have an exceedance.
The subject of alarms. Often alarms are going to be your first indication that you have a problem. Could be just an informational alarm, could be a genuine alarm, it could be a nuisance alarm, but regardless, alarms need to be programmed into the system and they should be communicated real time. And there are multiple methods of doing this. Your dashboards can do it. You can get alarms via Modbus, whether we're talking serial or Modbus over Ethernet, email capability, simple message system capability via your database engine, pumping alarm indicators to annunciator panels in the control room, the front end of the DAS itself, and these can be pumped to whoever needs them, whether we're talking about your controls group, your operations group, environmental folks, anybody else who has skin in this DAS, keeping an eye on it. You can get alarms for these things at will when you want them, sometimes even when you don't. And that's when you need to employ some intelligence with the alarming. Let me repeat that, intelligence with alarming. Because if you have an alarm that just pops up, drives you crazy all the time, we call that nuisance alarm fatigue. And when that occurs, that generally becomes an alarm that people tend to ignore. Important alarms can and should be latched, meaning that the alarm message stays up there until the condition is corrected, until that fault is taken care of and the alarm goes away. The alarm is for what must be corrected quickly. An intelligent alarm is for what must be corrected quickly. And you still have other tools available to you for monitoring that. You have the dashboards, the charts, the values to your DCS and PI system, whatever you use at your facility. You should always use intelligence when you're asking to have these alarms configured on your system. And you should be studying them periodically to determine if they're truly important or if they're simply informational and can be safely ignored. And finally, we come to our daily checks. And I'm going to direct this part of the conversation to the people who routinely look at their DAS. On a daily basis, you should be examining your alarm screens. You should be looking for those alarms that are going to definitely constitute an exceedance or a downtime period. Be aware of them. You should be examining and verifying that your daily calibrations are occurring when you expect them, that they showed up a short time after the calibration was complete, that you should be examining hourly reports for both value and status flag and look for anomalies on either. You should be looking for any communication glitches, any hiccups. If you see an hourly value that doesn't make sense to you, you might want to drill down to a more base average level and find out if a problem occurred. If you had some kind of communications glitch that kept you from collecting information for the entire hour. Routinely, you should be verifying when your certification or recertification tests are due. And if you've already completed them, what do those results look like? You should be at least cognizant of any changes in operations and how that's going to affect the values or status of your data going forward. And finally, you should just look for any crazy stuff that just happens. And I'm sure there's plenty of examples out there, but any crazy things like, okay, why did I suddenly go over, why did I experience it? Did I really have a full scale exceedance? Did I really just go over scale on my analyzer, or did something crazy just happen? Look for the weird stuff. This is CEMS. Weird things can happen for no other reason than they just do.
And we're discussing DOS here, but your DOS for anything bad that can happen could be programmed in with certain alarms. Some of those alarms for these routine daily checks are someone left the door open on the CEMS shack, and you get an air conditioning alarm. So simple stuff like that can create calibration failure, can create exceedances, and your DOS should be telling you the health of the overall mechanical condition, as well as you personally going into that CEMS shack daily and looking for things like on a dry extractive system. Take a look at the peristaltic pump. Make sure that there's not a lot of moisture building up or backing up into the AC unit. Very simple checks, visual checks that take 30 seconds to do could save you a lot of time or even downtime, operational downtime. And the daily checks should be a team effort. And I know that some facilities may have a different arrangement, ICE techs, operations people, EHS people. I would encourage the engineers and the EHS folks to shadow ICE. And that's how I learned. I personally would go out with ICE and say, look, show me what you do on a daily basis on these routine daily checks, because I'm the person standing in front of the DOS validating all of the data. And so I wanted to make sure I knew exactly what I was looking at, and that when I put a code or a flag in, that I physically checked on these daily checks.
That's very true. I mean, we're going out for auditing purposes, conducting mock audits. Part of our routine is to actually ask questions. What does your daily routine look like? What are you looking for? How often are you training on this stuff? What would what would you generally identify as a problem in the system at its most base level? Show us how you do your jobs. What are you looking at on a daily or a weekly basis as far as verifying the operation of these systems, that everything's looking normal? Are we talking about a cold dry extractive system here, or a dilution extractive system? Something to that effect. Adam, have you figured out the question section
I
of
have.
the webinar yet? Okay.
Yes, so now we've got some great questions here, and I've got a list of some are specific to ESC. So let's talk about the specific to ESC Stackvision questions. If anybody has customer support, Stackvision specific questions about your specific implementation, we are going to have customer service reach you directly, and we're going to walk you through and get you a response to that. Some of these other questions have to do with valid hours and also data historian. There's some questions about ECMPS and algorithms for data compression. There's a question here. Let's start with great presentation. Well, thank you so much. We've had to brush up on our presentation skills with this current situation of lockdown, and it's a pleasure to do this for you, everybody here today. Is this going to be recorded, and can we have access to it? Sure. We're going to provide you a link, and you will be able to view this at any point in time at a later date. Now let's talk about valid hours. Somebody asked a great question here. How does a valid hour apply to a linearity? And so I recall that I was talking about maintenance event and that you can optimize an hour to not be invalid based on when you start your maintenance and come out of maintenance. That also applies to linearities, because a linearity and maintenance, linearity is a QA event. So QA events only need two valid quadrants in 1 hour to constitute the full hour as valid. So theoretically, if you start your linearity at 16 minutes and you come out of your linearity at 44 minutes of the next hour, you have 2 valid hours and you've met the criteria. So I hope that answers your question. And you say backup or PI. What other type of storage, unless it is changed, the EPA will not allow a non-certified source? Where was the change? This is an excellent question. So I've run into situations before where the entire DOS server crashed, complete kaput. We had a power surge and the backups were not good. So the shame on us for not taking proper backups. We did, however, have the OSI Soft Pi system for the plant that had minute-by-minute data. We had to work individually with the agency, and this is correct assessment here saying EPA will not allow non-certified data. That is a true statement, but on a case-by-case basis, if there is no other alternative and you have to go submit your EDRs, I do encourage you to work with Washington, D.C. So the folks in charge of ECMPS in D.C. are very understanding. I've had zero issue with communicating my failures with them over the last 10 years. And in the case that you do have an extreme situation like we had, you should go to these alternative sources. Now, that being said, a backup of your DOS and a backup of Pi are not the same thing. And a backup of your DOS should be maintained, and you should have 5 years worth of data, and you could be held accountable for that if you don't.
That is true. All of that, yeah.
One of my favorite subjects here is data compression. What do you do with historians that have data compression turned on? There really isn't a way or good answer around this, because that's what historians do. You have to compress the data because the amount of sampling rate or sampling time, it dictates the storage requirement. You can't sample infinitely, so you have to pick a sample rate, and then it interpolates the data between point A and point B, which could cause a difference between what your DOS is reporting versus what your historian is reporting. So it shouldn't be an issue as long as you're not using your historian for calculating emissions, which technically you shouldn't be because you have a certified DOS. So it shouldn't be an issue. Same question for ECMPS, oftentimes not matching the data. Well, ECMPS is going to do what ECMPS does. It's going to take your data in and it's going to generate a value, and it's going to give you critical errors if there are any. It's going to give you the emissions file that you can go download later and take a look. I've never run into a situation where there's like an order of magnitude difference between what your DOS is saying versus what ECMPS is saying. If you're seeing an extreme example, I would love to see it. Send us an email, send Steve or myself an email. I would love to see that situation in real time. Does our system 8864, so the Stackvision data controller 8864 versus PLC, does the Stackvision 8864 do the calculations? The answer is yes. So on our own brochure marketing material, if you will, the answer is raw data storage, validation records, compliance calculations, flags, and data that's invalid. And so we're storing that locally for up to a year on a device. The PLC method, you might not have that. So PLC is going to have the raw data, and that raw data then gets sent to a DOS, and that DOS is now doing the calculations where that's stored on a computer server somewhere. And so if you're in the PLC method, if you have PLCs at your site, I highly recommend you figure out where that data is going. Let's look at these other questions here. I think that, maintenance mode is calculation valid data for both part 60 and 75. Yes, so the valid hour for 60 and 75 is the same. So
That's part of the harmonization rule they're talking about.
Exactly. So
yeah,
for a power plant, and I realize not everybody on this call right now works at a power plant. I just happen to come from the power industry. So my experience back in 2008, when we first started doing the Part 60-75 harmonizations, this was a key piece of this. And I would like to note that every power plant here on this call is still Part 60 because of CO. So if you have a CO analyzer at your site that is not covered by Part 75, now there are case-by-case basis where you've went to an agency or your permit says you shall do Part 75 and it has included CO as a part of that equation. But the technicality is if you go look at the regulations, Part 60 covers CO. So everybody that works at a power facility on this call should go back, review to see how that CO analyzer is being maintained. Are you doing a CGA? Are you doing a linearity? If you are doing a linearity on your CO analyzer, how is the DOS recognizing it? Also, does the agency recognize the linearity as a CGA? So those are some very critical questions to ask yourself. If anybody has any questions about that specifically, or you find something different from how you're managing CO versus all the other analyzers, NOx, then you should contact us. You should give us an email and say, hey, this is a question that I have specifically regarding Part 60-75 harmonization. Let's see here, going through my questions here.
What else we got?
I've got a... Okay, we do have an answer for our customers that do have Spectra packs, and what is our plan of action as ESC Spectrum for supporting Spectra packs. So Spectra pack is our other data controller. 8864 is the current data controller. The Spectra pack will be obsolete, but it's going to be supported for 4 more years. The ultimate replacement in game is 8864. So we have an end-of-life notice that's posted instructions. We can send that out to anybody that currently has Spectra packs. So that is a email that will be sent out to anybody that's asked that question specific to Spectra pack. Does anybody else have any questions? Are you seeing my questions? Yes, I am. I think I've gone through all of them, Steve. So these are very good questions. I really appreciate everybody taking the time to type these in. If I do find that I've missed one, I apologize in advance. I am, after this presentation, going to go back, re-review everything that was asked here and make sure that we reach out to you personally and say thank you, and also with a response.
Okay, great. Thanks, Adam. And there's some ESC Spectrum resource and contact information for you. There's the Spectrum website, a main resource library that is available to everyone who wants to take a look. Presentation on staying ahead of the data review game. Any general inquiries that you have with regard to ESC and Spectrum offerings, and Mr. Jackson's contact information, ajackson@advirasys.com. There's his number.
Yep, I would encourage folks that if you do have questions, text me. And I work power plant hours just like you do. So if there's anything, I don't care if it's 11 p.m., 2 a.m., 6 a.m., and you have an issue and you can't find a response, text us and we will find you an answer.
Which also means he takes power plant breaks, which is pretty much any time he pleases. But yeah, Adam's pretty good about answering everybody's questions when they come in. But here's Trinity resource and contact information for me, trinityconsultants.com. I am SO Argabright at trinityconsultants.com. And with regard to the publications that we're referring to, Part 75, if that is applicable to you, I make heavy use of the Plain English Guide to Part 75 and the Emissions Monitoring Policy Manual. Both of these are readily available online. You can do a soft search for them at will and bring them up. On behalf of ESC Spectrum and Trinity Consultants, I'm Steve Argabright. Thank you very much. Good day.